Now for this part of the tutorial, let's actually do an example that applies inverse matrices to real problems. So let's take a look at example 3. So here we have a system of two linear equations, and if we want to solve them, rather than using substitution or elimination method, we could also use matrices. So what we need to do is take this system of equations and change them or convert them into a form that would show this system as a matrix equation. So in very basic terms, we want to have a matrix with the coefficients of our variables times a matrix that has our variables in it. And that's going to equal a matrix with our constant values. So for example 3, if we were to set it up like this, we would first have our coefficient matrix. Now in the first row, we want to have the coefficients that are in equation 1. Now in the first column, we want the x coefficient, and in column 2, we want the coefficient for our y. And then similarly, in the second row, we want to have the coefficients from the second equation. So we'll have the coefficient for x in the second equation in our first column here, and then our coefficient for y, also from the second equation, will be in the second column down here on the bottom row. Now when we set up a matrix with our variables, the variables need to be in the same order as they are with our coefficient matrix. But rather than having them in our columns, we're going to have them separated out into different rows. So for example, with this variable matrix, the first row will have our x, and the second row will have our y. Now, after multiplying these two matrices together, we should get the same values as we do in our system. So for example, in the first row, we have the equivalency, or the value that our first equation should equal. So since negative 2x minus y should equal negative 4, we have negative 4 in our first row. And then similarly as well, we want to have our constant value from the second equation in our second row. So that's why 14 is there on the bottom. Now so far, what we have is our setup, which looks like this. So this is just another way to show this system of equations, but rather than having it as a system, we have it as a matrix equation. Now if we want to solve this system or solve this matrix equation, we want to find out what x and y are. So essentially what we need to do is isolate this matrix that has our variables. Now in order to do that, we need to get rid of this coefficient matrix here on the left side. Now this is where inverse matrices comes into play. So if we want to cancel out this coefficient matrix, we need to multiply it by its inverse. Now if we do that on one side of an equation, we also have to do the same thing on the other side of the equation as well. So our next step would be to multiply by the inverse of our coefficient matrix. And again, we need to do that to both sides to maintain the equality. Now like I said earlier, if we take the coefficient matrix and multiply by its inverse, it'll cancel out. So now this is gone from the left side. So after doing that, we're left with this. So at this point, we have isolated the matrix with our variables. So in order to actually find the values for x and y, all we need to do is take the inverse of this matrix here and multiply it by our constant matrix, or the matrix with our constant values. Now this inverse matrix here probably looks familiar. And it should, because it's actually the matrix that we took the inverse of in example 1 of this tutorial. So rather than going through all that work again, we could just use the result that we found from doing that. So let's plug in that resulting matrix in for our inverse. So now that we have everything set up, let's actually go ahead and solve for x and y. Now let's start with x first. So if we want to solve for x, we need to look at the first row and first column. Now, for our first matrix, we'll do the first row, and then we'll multiply it by the first column. So when we do that, we get x equals 1 times the negative 4 plus a 0.5 times 14. Now when we simplify this, 1 times negative 4 gives us negative 4, and then plus a 1/2 times 14, which gives us a value of 7. So x is going to equal negative 4 plus 7, which gives us a value of 3. So in our resulting matrix, in the first row and first column, we'll have a value of 3 for our x variable. Now let's go on to solve for y. So now that we're looking at y, we need to do the second row of our first matrix times the first column of our second matrix. So when we're solving for y, we need to do y equals a negative 3 times negative 4 plus negative 1 times positive 14. Now when we simplify this, a negative 3 times a negative 4 gives us a positive 12, and then plus a negative 1 times a positive 14 gives us a negative 14. So y is going to equal 12 plus a negative 14, which is the same thing as 12 minus 14. So our y will have a value of negative 2. So in the second row and first column of our resulting matrix, we'll have a value of negative 2. So in the end, when we solve for our variable matrix containing x and y, it turns out that the values end up being this resulting matrix here. So x is going to be 3 and y is going to be negative 2. So that would be our solution for this particular system of linear equations. And that wraps up our tutorial.